Wanted to keep going with this example of the bottling factory and the information the book gives us on the production function and the costs in that bottling factory. Wanted to make sure you understand the connection between table 6.1 that gives us just the production information and table 6.2 where the costs are added. And I want to make, it's really important that you understand where those costs came from. So here's the information on production. I put it into a spreadsheet, but it's just the information in table 6.1, and then I've left blank the columns that I'm going to talk you through. The key thing I want to show you is that the book just adds some important information on factor costs. In particular, the rental rate of the capital that the firm employs is $40 per day. That's pretty cheap, but that's just given information. And so $40 a day is the rental rate of the capital that we have. We usually use small r for that. Just not sure why. Probably David Ricardo back in the early 1800s used it. And here we are 200 years later doing the same thing. Wages are they're given by the book as $12 per worker per day, and that's even less than what they're making in China. So either it's 1800s United States or someplace where they pay even worse than China. But we're just going to take it as given and then use that to derive all the information in this table. Let's move to do that. Total fixed costs are just total fixed costs. They don't change. So it's 40, 40, 40, it gets sort of monotonous, but total fixed costs are just whatever fixed costs are, that's what they are. They're fixed. They don't change with output. Workers, though, are the only variable input. We're just abstracting away from intermediate inputs. You'd have to buy the sand that's going to be heated to make the glass, the electricity, all that. We're just assuming no, it's just labor and capital. Anyway, the total variable costs, if you're hiring 0 workers, you don't have to pay them. It's just 0. But as you add each worker you add, you have to pay this measly wage of $12 a day. So 2 workers are going to cost you $24. That third one's also going to have to be paid. So your wage bill is going to go up to $36. And now we're skip counting by 12s. But that's where these variable costs come from. And then total costs, all costs are either fixed or variable, so we just add the fixed costs and the variable costs to get total. And that's really what you need to know about where these cost functions come from. Notice that our fixed costs are going up by 12 each level of output because we've mapped how output goes up as we hire one more worker, one more worker, one more worker. Now, marginal cost. That's something different. Marginal cost is, we're going to have to do some new thinking for marginal cost. Marginal costs, when you hear marginal, you know you're going to be dealing with a ratio of the change in one thing divided by the change in something else. For marginal costs, it's the change in total costs, which, by the way, happens also to be the change in total variable costs, divided by the change in quantity. So either the change in total costs or the change in total variable costs will get you to marginal costs. And remember, fixed costs aren't changing, so delta TFC is 0 all the time. So anyway, that's marginal cost. So I'll set these problems up, and then I'll maybe pause it and use my calculator if I need to take this example home. But for marginal costs, let's see, total costs, we remember marginal costs are as we move from 0 to 80 units of output, as we move from 80 to 200. So we actually map the marginal cost at the midpoint. We'd map it at 40, 130, 230. And so on. It actually would be 140, not 130. I misspoke. All right, so marginal cost. We're going to look at the change in out in total costs, so that's 12. Then we're going to divide that by the change in output, that's 80. And then notice that the change in cost is always 12 for reasons that I hope are quite clear. We're just adding one worker. This change in output, though, is 120. The next change in output is 60. I hope you're seeing the similarity between this problem and the Harry collecting recycled cans. Very, very similar structure of what's going on here. 12 divided by 40, 12 divided by 30, 12 divided by 20, and finally 12 divided by 12. All right, so what's going to be the price of these bottles, or the marginal cost of the bottles, which tells us the seller's reservation price, just as we learned in class today, 0.15 cents per bottle. Or actually $0.15 per bottle, right? 15 cents, but $0.15. All right. Then notice that marginal cost falls. That's because marginal product rose as we move from 80 to 200. But then we're in a range of diminishing marginal product. So we're going to need 20 cents before we're willing to supply 200 bottles to market. 30 cents before we're willing to supply 206. Let's see, 20 cents got us to 260. If we're going to be willing to supply 300, we're going to need to get 30 cents a bottle. If we want to up it to 330, we're going to need 40 cents a bottle. $0.60 a bottle to be willing to supply 350 of them, and a full $1 a bottle before we're going to supply 362 to market. Anyway, that's where these come from. Now, I'm going to, in the next screencast, I'm going to show you how to think graphically about the firm's output level and all that. But if you're being asked to find the profit maximizing level of output for a firm and you're given information on production function and costs, as you often are, we can always just calculate total costs and then move to calculate total revenue and then profit and just scan for the highest profit outcome, and that's the one the firm's going to choose. And that'll get you to the answer in this type of problem. Let me just remind you of two formulas and then end this screencast. Total revenue, you need total revenue to get to profits. That's the benefit side of things. But we've done that before. It's the price, how many dollars per unit you get, times how many units you produce. So if you get $10 a unit and you produce 1,000, you're going to have 10,000 in revenues. It's as simple as that. And then profits is total revenues minus total costs. The previous page talked through how you get to total costs. The total revenues is price times quantity. Subtract total costs off of total revenues, you're at profits. And in this class, I will generally either make it very clear what's explicit and what's implicit costs and actually explicit and implicit benefits too. If I just tell you costs are whatever, if I don't specify implicit, explicit, always assume that I'm talking about economic costs, which is the sum of explicit and implicit costs.
Made with Doodlecast Pro.